Okay, so chapter 8 is about lines, and of course we're not going to be able to cover line, yes. Yes. Well, it's more like Algebra 1 where you plot functions. Are you good at geometry? Well, I mean, geometry has to do with lines, but not. Actually, before we started that, I had a comment to make. So, yesterday, our illustrious president, or at least his Treasury Secretary, talked about the biggest tax cut in American history. It's huge, and it's amazing. Yeah. So we talked about tax implications of buying a house. One of the big things that the plan would do, which is probably not going to happen, but we'll see what happens. So the standard deduction for a married couple right now is $12,000 per couple. And what they're talking about is raising that to $24,000, which, you know, is not, I mean, it's not going to hurt. It's going to help me because I do the standard deduction. And so how much extra money would I get based on that particular change? Well, what you would do is you take $12,000 and multiply it by your tax rate, which mine's 15%. So 12 times 15 is about 15, so it's about $1,800. So I would save $1,800 in taxes. The problem is that if you remember me talking about the homeowners, the mortgage deduction, it would pretty much mean people who are buying modest homes would get no benefit from buying a house from a tax perspective. They would get more money, but there wouldn't be the incentive, there wouldn't be the selling point that you would save taxes if you had a mortgage. So the real estate agents don't like that idea. Well, they don't like the idea of actually getting rid of the mortgage deduction, but it's essentially getting rid of the mortgage deduction for a lot of people, but also giving them more money. So here's my theory. You know, over the years, Republicans, every time the Democrats are in power, the Republicans are always so into deficit. Oh, the deficit. We can't spend money on this. Blah blah blah. The deficit. So as Republicans come in power, you don't seem to hear it anymore. And so what this tax plan would do is basically give, for the most part, give a big tax break to rich people and to corporations, and maybe some to the middle class. But there's no. They always use this excuse that the higher economic growth is going to bring in more taxes, which is going to make it so. And that's never worked in the past, and so you can't count on that. It's like your friend, your friend who's always borrowing money and never giving it back. Oh yeah, man, this time I'll pay you back, right? And after a while you say, I don't believe you anymore. It's not really true. So I think what's happening is the deficit is actually coming down because the economy is doing pretty well, but it's not high enough that they can get all on their, they can say we need to cut all these programs, social programs that they don't like because the deficit's so high. So we'll just give you we'll give a big tax cut so we make the deficit go crazy so we can use that as leverage to cut back on social programs. I can't think of any other reason why they're so intent on the deficit when they're not in power, but they are when they are in power. They as a revenge for voting for a certain person. Yeah, so what they're doing is I think they're like 6 or 7 tax brackets now. So there would be 3 tax brackets. There'd be 10%, 15%, and 35%. So the ones that are in 20 and 25 and all the ones in between go down to 15%. Only the highest pay 35%, but the reality is that most rich people figure out a way of avoiding that anyway. So it's kind of a moot point. Um, the other thing too is, you know, you run into the thing, we have no idea what taxes our president who's pushing this pays, and therefore we don't know if it's in his benefit or not. And so, you know, a lot of people are saying that if he wants to even have a chance of this happening, he needs to release his tax returns, which for every other person in government, if you're a congressman or a senator, you have to disclose those things. It's just the president who doesn't have to. If you're a cabinet secretary, you have to disclose that stuff. But the president is above that particular law for whatever reason. Okay, anyway. Where was this now? Oh, Comedy Central roast. Oh, okay. So, in the last chapter, we basically had one unknown, or we made it so we had one unknown, and we solved for that unknown. And it used certain skills in algebra to do that. The next level of complexity is you have something that doesn't just have one value, it has a value based on some other variable. And the easiest way to, there's different ways of representing that. One is an equation. Another way is you could put a table of data together, just show particular data points. Or you can plot the points on a graph and show the graph. And the graph is probably the most useful as far as looking at the relationship between how you change one variable and how that affects changing another variable. So speaking of taxes, you know, what you may have is something like this. Some guy would say, you know, what they're hoping is if you plotted tax rate versus economic growth, and so what they're saying is as you lower the tax rate, the economic growth goes up like this. Okay. It provides incentives for people to work harder and make the right decisions, or be you know, invest money in businesses. And therefore, if you plotted tax collected versus tax rate, what you would see is something that looks kind of like this. They think it goes this way, I guess. So as you lower the tax rate, you actually, even though you're taxing people to a lesser percentage because the growth in the economy is more, they're making more money and such and so forth, so they're actually collecting more taxes. Usually that doesn't happen. What happens is usually something like this, where you don't collect, you know, tax rate's low, you're just not collecting taxes, and then you increase your tax rate, you get more taxes, but at some point the tax rate becomes so high that people find ways of avoiding taxes, and therefore it drops off. And so again, we're using a two-dimensional plot to relate the change in one variable to the change in the other. And a lot of times that relationship is simple. It's a linear relationship. So we looked at this thing the other day. You know, if somebody does an experiment and they plot if you plot displacement or stretch of the spring versus force, you would plot a few points, and you would see there's a definite relationship, and if you fit a curve to it, you'd find out that you have pretty much a straight line through it. And this is something that's seen in real world situations, and it governs all kinds of things that happen with physical phenomena. Okay. back to just the math details here. So what we do is we have what we call the Cartesian coordinate system. It's just your grid, and we have the the way you plot a point, the relationship between one variable and another is you have what we call an independent variable, which is usually we call that x, and we have the dependent variable, which is y. And if you want to know for a particular value of x, what is y, we represent it by a point. And we represent that position as a coordinate pair. So we have the x value, which we just count in the x direction, 4 units. And in this case, we go in the y direction, 9 units. And that uniquely defines a location in that coordinate system. In calculus, we're talking about polar coordinate systems, which are another way of specifying a point in two-dimensional space. And there you specify the distance from the origin and the angle that the line from the origin to the point makes with respect to the positive x-axis. So there are other ways. This is not the only coordinate system that you can use. It's just the one that's most often used. And we designate the different areas where the signs are either the same or different, as we call those quadrants. So we call the quadrant where the x value and y value are both positive, that's the first quadrant. Where the x value is negative and the y value is positive, it's the second quadrant. Where they're both negative is the third quadrant. And where the x value is positive and the y value is negative, that's the fourth quadrant. Most things happen in the first quadrant. You don't usually deal with negative quantities, but you can deal with negative quantities. So the first thing you need to know how to do is to plot a point, but you've done that forever, so we're not going to belabor that. In section 1, pretty much there are 2 things that we're going to ask you to know how to do. One is the distance formula, and what this is an equation for figuring out the straight line distance between 2 points plotted in the Cartesian coordinate system. So this represents point x1, y1. They're both going to be negative in this case because they're in the third quadrant. And this is x2, y2, which is in the first quadrant because they're both positive. And this is the distance. And you can see, though, that what I've created by drawing a line between the 2 points and then drawing a vertical line from this y value to the y value corresponding to this point. And the same thing here, you end up with a right triangle. And right triangle geometry says that this a squared plus b squared equals, in this case, d squared. And d is the distance between the two. So the distance formula is just the Pythagorean theorem applied to this particular example. So it's, is this an important thing? Do people actually use this besides when they take algebra or algebra 1 or algebra 2? And the answer is yes. We use it in physics. For example, if we want to, one of the fun physical phenomena is it's like static electricity. You know, if you take a balloon and you rub it on your head, the balloon gets charged, one positively or negatively, and then you can put it near a wall and it'll attach to it because of static electricity. So you can quantify that amount of force by using a law, which one of the parts of the law is the distance between the 2 points. So if you want to know, to be able to solve that force, you've got to know the distance, use the distance formula. Okay, so there are hundreds of examples where the distance formula is used. So let's just look at an example. So what I would do is I'd ask you, what is the distance between points, say 2, 5 and 5, -7? Question mark. Now I'm just going to draw a simple sketch to kind of give me an idea where these things are. So 0.2 comma 5, you go 2 in the x direction, 5 in the y direction. So that's 2 comma 5. And then 5 comma negative 7 will be somewhere down here. And what we're looking for is the distance between the 2 points. So this is one thing I suggest to help you make sure you don't make mistakes. It's not a hard process, but I've seen people make this mistake, and this is a way of getting around that, is you actually want to go ahead and actually write out x2, y2, and x1, y1 above the points. Because usually what happens is people are in a hurry and they try to look from those numbers and try to figure out which one's x1 and which one's y1. They get x and y mixed up, and they get 1 and 2 mixed up, and that's the biggest error people run into. So by putting these right above the numbers, you're less likely to run into that situation. So I'm going to write out the equation. Y2 minus y1 squared plus x2 minus x1 squared. So we just are very careful about making sure we do the numbers correctly. So y2, I go up here, I look down, I say, okay, that's negative 7. Subtract y1. So y1 is 5, so I subtract 5. I square that. I need x2, which is 5. And I subtract x1, which is 2. And I get that. And then the next most likely thing is somebody's going to do this math incorrectly. So negative 7 minus 5, you start at negative 7, you're going more negative. So you add the two numbers together and then change to a negative sign. So it's 5 plus 7 is, because they have the same sign, you add them together and then you make the sign negative. And you square that. And this one's easy because that's 5 minus 2, which everybody should be able to do. And so finally, you can do that with your calculator. You'll end up with the square root of 144 plus 9. And because you square it, you always end up with positive quantities here. So that's going to be the square root of 153, whatever that is. If I ask you to do one for the class, for the exam, you can just leave it as a square root. You just have to, basically what you have to do is you have to realize what I'm asking you for, and you do the math correctly inside the parentheses. And then you square them. So the last part is just plug into your calculator, so you don't even need to worry about that. Okay, the next one, the only other thing here is the midpoint formula. So that is giving you the coordinates of a point that's midway between the two endpoints. So what you have is you have a line segment where one end of the line segment is x1, y1, and the other end of the segment is x2, y2. And all you have to do is add the coordinates together and divide by 2. It's going to be halfway between, midway between. So again, if I give you a problem, you just say, oh, it's a midpoint problem, so let me get the formula out. And you know, as I said, that this formula is used a lot. This formula is rarely used, but we're still going to make sure you can use it. So let me pick two other points. Find the midpoint between points -2, 7, -3, 7, and 5, 4. Okay. So all we have to do now to find the midpoint is a coordinate, and again I'm going to write down x1, y1, and x2, y2 to minimize the chance of me making a mistake. So we have x1, which is -3, plus x2, which is 5, divided by 2, And we have y1, which is 7, plus y2, which is 4, divided by 2. So we end up with 2 divided by 2 minus 11 divided by 2, which is 1 comma 11 halves. So let's go ahead and just plot this on a graph. And show you that you can do a pretty good job of approximating the midpoint just by looking at it visually. So the first point is -3 comma 7, that's up here, and 5 comma 4, which is here. So we draw a line segment between the 2 points. And so I would guess it's about right, maybe about right here, somewhere like that. Just looking at it, looking for this distance and that distance. And I see 1 comma 11 halves. So I have 1 comma 11 halves, so I got it exactly right. I got lucky there. You know, you should be at least within this range if you just eyeball it. So that allows you to check the answer to make an approximation. If you got something, you know, if your midpoint ended up being here, obviously you've done something wrong if they were both negative. Okay, that's it, section 1. We're done. So you got a couple problems. You have to calculate the distance between 2 points, and a couple problems you calculate the coordinates of the midpoint. So these are all due at the exam. So you'll have section 1 and 2 for the exam. Turn those in. I think it was, what was it, 10:30 to 12:30? So yeah, because the previous one's from 8:15 to 10:15, and they have 15-minute breaks. So it's 10:30 to 12:30. One last comment before we move on, just is this word independent versus dependent variable. You know, by convention, the variable that if you're doing an experiment or you're relating one thing to another, the variable you have under control is the independent variable. You control that, and then something happens because of changing the x variable. So the y variable depends upon what happens with the x variable. That's why it's called the dependent variable. So I used an example yesterday. Let me think if I can think of another one. If I did age or year produced, this is for cars, and average gas mileage. So I would choose year produced as the independent variable. Not that I can change the year, but that's usually something that you can determine simply by knowing the model year. So it's something that's specified easily, and there's probably some type of relationship that may be linear. And so then the dependent variable would be the average gas mileage for that particular year. And you'd see some relationship between that. That's another thing Trump wants to do, is to get rid of the standards for mileage. Is it already done? Yeah, which right now, people have such short memories, you know. In terms of fuels, I don't think I'll live long enough to see it, but my children probably will. You're going to run out of fuel sometime. There is not an infinite supply of fuel. Uh, so the better efficiency standards you have, the longer it is until you're going to run out, which means it gives you more time to figure out what the heck you're going to do about not having fuel or not having raw materials to make plastics. And why they can't see that, I don't know. Just pardon me? Oh, they found a caterpillar. There's something else I read the other day I was going to tell you guys. What was it? Oh, I know. I posted this link on Facebook. The United Kingdom, they were predicting that they would go an entire day without using fossil fuels. So they were just going to be using renewable. And it was because it was before summer came and after winter ended. You know, this is the period of time that I use the least amount of electricity in my house because I don't have air conditioning, I don't have heat. And the same thing applied there. And also, you know, there are other variables. I forget what they were in terms of holidays. It was, you know, I think it was a school holiday. So, you know, there were just a lot of factors. So it was not something they could do sustainably, but it was the first time since, you know, whatever time the Industrial Revolution where they didn't. Well, no, it wasn't fossil fuels. They didn't burn any coal because, yeah, they can't get to that point yet. They're burning natural gas instead of coal. But considering how dependent they were on coal at some point. So that was pretty impressive. People in Europe seem to have a better understanding of science. Yeah, that's right. I did have some of my former students go to that march they had last weekend, the one on science and facts and reason. One thing that amazes me, you know, I'm an engineer, and I think, you know, I know the way I think relative to, you know, you think engineers would be fact-based people, but it's amazing how many engineers buy into the whole not thinking. It's disappointing. Okay, anyway, the second section is about linear equations. We're not going to get to talk about the point-slope form or the slope-intercept form. We're just going to talk generally about lines. And again, it may think lines are so simple. Why are we even talking about them? But the reality is, again, a lot of things in science are straight lines. So just having some understanding, looking at a line and saying, oh yeah, that means something, or this shape, this slope means something. So I've got two lines here. I've got a blue line and a red line, so don't cross the red line. And what kind of characteristics, you know, if I move this thing around, how can I characterize this particular line? Well, one thing is, you know, this obviously has the same inclination. The change in y divided by the change in x stays the same. But as I move it around, the x and the y intercepts change. Where it crosses the x and y axis are important. Now, they're not only important just because they help determine where the position of this line is, but they also, again, in real world, cases where you have 0y or 0x are significant. In calculus, where we spend a lot of time is figuring out where the value is 0. X is equal to 0. That's maybe the solution to your problem. And the y-intercept is where your independent variable goes to 0. So that may be something like, what's a good example? I always use this one. If you look at the pressure and temperature of gases, if you keep lowering gas down to a lower and lower pressure, you'll measure a lower and lower temperature. And if you extrapolate all the way down to 0 pressure, you get an intersection, and it turns out we define that as absolute 0 temperature. And it actually has a linear relationship. So, you know, where it crosses the x and y axis is important. Also, how steep it is and whether it's, if you're going from left to right, is it increasing or is it decreasing? In this case, they're both increasing. And we call that change in one variable compared to the change in the other variable. We call that the slope, which again you've had before. So here is, in the previous section we talked about a linear equation in one variable. So in one variable it looks something like ax plus b equals c. So the only difference is that instead of b just being a constant, you've got now two variables. You've got x and you've got y multiplied by some constants, and that's equal to some other constant. And it says where a and b are both not 0. One can be 0, then you'd have either a vertical or horizontal line. But if they're both non-zero, then you have a line that's at some angle relative to the horizontal. And the two variables are x and y, and it's called linear because x and y are just, they're not raised to a power. So if I had x squared, it would be nonlinear. If I had the square root of y, it would be nonlinear. But again, a lot of situations in real life are linear. So it is a useful relationship. And this is called standard form, where you have both variables on the same side of the equation, which is different. You know, if you remember back to algebra, the one you're probably most used to seeing is y equals mx plus b, where you've solved explicitly for y. And that has usefulness, but the actual basic standard form of a linear equation is where both variables on the same side. Off to Mr. Sass. What are you guys doing today? Oh, okay. So somebody may ask, well, what's the usefulness of having it in a standard form? We know the usefulness here because we can find the slope of the line and we can find the y-intercept. And the answer is not a whole lot. The only advantage of having it in standard form is it sets it up to finding the intercepts easily. So it makes, which we'll show in a second. But it's just some definition. There are other equations that are in standard form where they put all the variables on one side and put the other stuff on the other side. So I think it's just kind of a mathematical, to be uniform in how you do standard form. If you remember, notice this one, the standard form for a one variable equation was very similar. Because you think, why do I need b over here? Can't I just put it on the other side? And the answer is, yeah. And the only reason I can see it is because it fits this one. It matches the linear equation one. So I don't know how they came up with that. Yeah. Yeah. So to find the x and y intercepts, which as I said are really important quantities, and whether you're doing it for linear equations or for any equation, the procedure is the same. It's easy to solve for x when it's a linear equation. It may not be so easy to solve for x when it's not a linear equation. So it's just a harder process. But to find the x-intercept anytime, you set y equal to 0 and solve for x. And to find the y-intercept, you let x equal 0 and solve for y. People mess that up, so if you have any confusion, just write it down and follow the instructions. So let me just make up an equation. So let's say 5x minus 2y is equal to 15. So there's my linear equation in standard form. So if I want to find the x-intercept, that says let y equal 0, solve for x. So I say 5x minus 2 times 0 is equal to 15. And this term drops out, so you just get 5x equals 15. Divide both sides by 5. And you get 3. So you were just solving a linear equation in one variable. Okay. Now that is not a x-intercept. That's a line. That's a vertical line. So to be exactly correct, the x-intercept is a point, and it's a point where the y value equals 0. So it's going to be 3, which is the value we calculated times comma 0. So that's the x-intercept, not that. If you said the x-intercept is at x equals 3, that'd probably be okay, but just putting x equals 3 is a line. Yes? Yeah, that's what 3, 0. That is the x-intercept. Well, it goes through that point, but it doesn't. It also has a lot of other points. So you could, like I said, if you wrote out the x-intercept, I guess you could say the x-intercept is the intersection of this line with the x-axis. Maybe that would be. So it's. I mean, I probably wouldn't mark off because it's kind of people do that. I do that sometimes, but technically you're supposed to put the point down as the x-intercept, not just say x equals 3. Which one? This one here? Yeah. I mean, it's not that bad. In the order of bad stuff, that's a minor thing. Okay. So I wouldn't, I'm not gonna. I actually used to do this myself, and then after the years, I've decided I like this better. So. Yeah, yeah. Once you get the two intercepts, you can draw a line, which we'll do in a second. Yeah. So you can use these two intercepts to draw a line. So we'll do that in a second. But let's just get the x and y intercepts. So for find the y-intercept, you set x equal to 0. Solve for y. So we say so x equals 0. So we take 5 times 0. Minus 2 times y is equal to 15. Y is equal to negative 15 halves. And again, we would put 0 comma negative 15 halves. I've just seen it enough that there's another way of doing it too, I think, but I can't remember what it is. Anyway, it doesn't matter. Okay. So let me see. Let me give you guys one to work on. See if people online are paying attention. So let's say we have 6x or negative 6x plus 4y equals 24. Okay, so what are the x and y intercepts? Yes. Yeah, I mean, you can actually do this one in your head. I chose numbers so that you didn't have fractions. So let me see who's online today. Melissa, Austin, Josh, Adriana. Okay. So Tanner's going to tell me what he got. What did you get for the y-intercept? Yeah. Yeah. So you set x equal to 0. You get 4y equals 24. Divide both sides by 4, you get 6. And then the x-intercept is going to be equal to negative 4. Yeah, because you'll have this term will go to 0. negative 6x equals 24 divided by negative 6, you get negative 4. Okay. Now you can, as you were saying, you can now plot the line given those 2 points. All you need is 2 points to draw a line. So we're going to have, oh, that'll hurt a little ding here. Oh, that must have been something else. Oh, Adriana came back. Okay. So anyway, so this point, negative 4 comma 0 is 1, 2, 3, 4, that there, and the y-intercept is 6, so 0 comma 6, 1, 2, 3, 4, 5, 6, and then you can draw a line between those 2 points. And I'm just going to extend it on. Once I have that point, I can, if you had a ruler, you just position your ruler so those 2 points are on your ruler, and then you draw the line. So what we can see is we have a positive slope, because as we go from left to right on the graph, the value is getting bigger, more positive. Now the only time, there's 2 times, well, there's a couple times this doesn't work that well. One is if you had your graph, if you had a graph something like this, where you're like that, and you are very close to the origin, or the 2 numbers are very close to each other, then it's hard to draw an accurate line with 2 points that are very close to each other by hand. In that case, you probably want to use some other way of drawing a line to be more accurate. The other one is, of course, right here. Just close my email so it stops coming up. If you go through the origin, the x value and the y value are both 0, and therefore there's no way to know, there's only 1 point, you need 2 points. So in that case, you'd have to find another point. And really, ideally, you want 2 points that are far enough, as far away as possible within the scale of the line in terms of the graph. So this is actually reasonably decent. But again, if they're really close to each other, the x-intercepts, then it's not so good. Okay, so we just did that. Let's do another one. So to find the x-intercept, so x-intercept, I'm going to do this one for you. The x-intercept, set y equal to 0. So it's always the opposite variable that you're setting equal to 0. So you get 2x equals 5. In this case, for the y-intercept, you set x equal to 0. So you get negative y equals 5. And so when you solve this, you'll get 5 halves for x. So the point is 5 halves comma 0. And over here, you get y equals negative 5. And so you get 0 comma negative 5. And you plot those. So 5 halves is right here. And negative 5 is there. And then you take those 2 points and you connect them together like that. You stretch it out. Like that. Okay. So make sure you can do that. Okay. And the last thing that we're talking about in this section is slope. So the slope is the measure of steepness of a curve. We all know what steepness is. It's a larger change from a mathematical perspective, it's a larger change in y for a given change in x. And if we're given 2 points in the Cartesian plane through which the line proceeds, we can use the formula for the slope. So as long as x1 does not equal x2, and that's required because of the denominator we go to 0, the slope of the line through 2 distinct points is equal to, so they've got all these different things. We've got m, which is the normal variable name that we use for slope. It's the rise, meaning how much we change in the y direction divided by the run, which you think of run being flat, I guess, not necessarily. So the rise is the change in y, the run is the change in x. And in terms of the coordinate values, it's just y2 minus y1 over x2 minus x1. So again, the hard part here is just making sure that there's two places people make mistakes most of the time, which is, again, they put the wrong numbers in. That's why, you know, they have the coordinates and they try to think about it instead of writing above the numbers what they are, and then that makes it a lot easier. So that's where people make a mistake if one of the numbers is negative and you're subtracting a negative number. You just got to be careful about that. So sometimes just being forewarned is enough to keep you out of trouble. Again, this is something that is used in physics. It's used in calculus. In calculus, the whole half of the first semester is dealing with something called derivatives, which is the slope of the tangent line. You derive the slope starting with this equation, starting with the equation for the tangent line. If you talk about physics, the speed of an object is the rate of the change in distance divided by the change in time. You can plot it on a curve, and you can plot those points on a graph, and you can say that the slope of the line is the speed, and the slope of the speed versus time is the acceleration. So the whole concept of slope is critical. For linear relationships, it's a very simple calculation. It's not quite so simple when it's not linear. So we're gonna work a problem here. So, well, first, no, before we do that though, we're going to look at the other way of plotting a line. So the previous case, we were given an equation which we found the intercepts from, plotted the intercepts and drew a point. I drew a line between those 2 points. In this case, I'm given a point and the slope. So I think that the thing that helps out here is, it says the slope is a half, and you can see the negative sign is in the front. But it's better to put the negative sign in the numerator. So if it's a negative number, rewrite it as -1 over +2. Because it could also be negative, it could be 1 over -2. And from a mathematical perspective, it doesn't really matter. But from using this information to draw a line, it's important to have the negative sign associated with the numerator. Because typically, we think of always moving kind of from left to right. We always think about moving this direction when we're looking at the graph. If it's got a positive slope, then it's increasing as we move from left to right. If it's got a negative slope, it's decreasing as we move from left to right. So we have this kind of inbuilt tendency to go from left to right. So because of that, this number is always positive. We're always going this way. So when we look at the slope, we can say we're going to go down 1 for every 2 that we go across. So we can go down 1 over 2, down 1 over 2. And I'm putting in points kind of lightly because I don't want to just use the first point that I come up with that has this relationship, because these 2 points are going to be too close together to draw an accurate curve. So you want to do that process of going down 1 over 2, down 1 over 2 enough times so I get a second point that's far enough away that then I can more accurately draw the line. And the other thing you kind of do is once you draw it, you go back and look and say, is it working? Is it actually crossing where I expected it to? You know, I'm going here, it should cross right here, it should cross right there, it should cross. You notice here this one's a little bit off. And as you get further away, it's easier to not have them aligned exactly. So I'm checking to make sure that every time I move down 1 and over 2 that I intersect the grid. And that's kind of one reason why you leave the slope a lot of times as a fraction. Because if I gave you this, if I said let's say point -3 comma -7, and the slope is equal to 7/9. What I would do is I'd go to this point, -3, -7, which is right here, and I can just count these. This is Y blocks or Y grids, and this is X blocks or X grids. So I would go 1, 2, 3, 4, 5, 6, 7 in the 8, 9 in the X direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I go 1, 2, 3, 4, 5, 6, 7, and I get my second point. And in this case, they're far enough apart that I probably don't need to I'd go off the graph anyway. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Okay. And the line can be drawn. When we do this in physics, we're a lot of times we're using this. We've got 2 points, and they may be charged particles, or we may be looking at the gravitational attraction between 2 points here. And it depends upon the distance. So again, from a grid perspective, you could go to the coordinates and you could use the distance formula, or you could just say, well, I'm just going to count some blocks. And I'd say, okay, I count 9 horizontally, square that, that's 81, and I count 7 vertically, which is squared is 49, so I add 49 to 81, which would be 130. So I know that the distance between those 2 points is the square root of 130 without even having to do any kind of formula. So if this number, the numerator and denominator numbers are large enough to get the 2 points far enough apart, then that's great. But if it's lower, smaller digits, it's usually better to go a fair distance to do that. Okay, the next thing is just to calculate the slope between 2 points. So notice that I have, in addition to having the 2 points, I have already gone ahead, and I'm not going to do it for you, but I would recommend that you do it, is to write x sub 1, y sub 1, x sub 2, y sub 2. So when you go to use the distance formula, the slope, and you have y2 minus y1 over x2 minus x1, it's much less likely that you'll make an error. So y2 is 5. I subtract y1, which is 1. x2 is 7. I subtract x1, which is -2. So in the numerator I have 4, and the denominator I have 7 minus a -2, but that's plus 2, so I get 9. So the slope's 9/4. As a word of warning, if you get -1 over -3, don't leave it that way. You should always simplify it. So that happens a lot. I've seen people do that. They just plug it into the distance formula and they leave negative signs. So always simplify if you've got 2 negatives. Okay, so that's it. You'll do some problems for homework on that one. There's the 2 special cases where you have a vertical line or a horizontal line. So I'm getting rid of this stuff for right now. So if I give you an equation, x equals 3, how do you know that's what the slope of that line is? To be tricky, I might do something like x equals 2/3. So it's a fraction. You're like, oh, the slope's 2/3, because you see a number and you automatically do that. But you've got to remember, you've got to have both x and y to have a slope. If you have just x, that is a vertical line. And if you plugged in 2 points on this vertical line, you would find out that you have the same x value. So the denominator would go to 0, the numerator would go to non-zero, and you'd end up dividing by 0. And any number divided by 0 is not infinity, but it's undefined. So we don't say this has an infinite slope. We say it has the slope is undefined. Which if I asked you draw a line where the slope is undefined, you'd say it's a vertical line. It's kind of like, one relates to the other. The only time that you can have an undefined slope is when it's vertical. There's no other configuration. And if you have a horizontal line, there the y value doesn't change, and therefore when you use the slope formula, the numerator goes to 0 and you get a 0 slope. So again, if you want to write this down to remind yourself, but if I give you y equals some number, that's a horizontal line with a 0 slope, and the x equals some number is a vertical line with an undefined slope. You don't have to use the slope formula to prove that. You can just say that's true. And positive versus negative slope. Again, we always define the slope, or think of the slope as moving from more negative to more positive values of x. We're always moving from left to right, like we write. So moving the value of the function, the value of y, increasing as you move from left to right on the graph, that's a positive slope. And the value decreasing as you move from left to right is a negative slope. So that's the definition of positive or negative. What would I might just show you a graph and say, is this a positive or negative slope without doing any calculations. So just remember those conventions. And we're going to skip that for right. Well, we'll mention it. So in physics and math, a lot of times the slope has a different name. It's called the rate of change. It's because it's the change in a value divided by the amount of time that it takes. Time is the independent variable, and change, whatever change you're talking about, is the dependent variable. So if somebody asks you to calculate the rate of change, it's the same as calculating the slope. We're going to skip over these word problems for right now and talk about the slope of parallel and perpendicular lines. So it says two non-vertical lines with the same slope are parallel. Two non-vertical parallel lines have the same slope, kind of the opposite. That's where the converse is true. Furthermore, any two vertical lines are parallel. So it's kind of a math, why do they go to this trouble? Because the slope of vertical lines don't have a value, so you can't have them equal to each other. So that's why you put slope, you just say two vertical lines are parallel. One thing people sometimes don't understand is for lines to be parallel, they have to be in the same plane. So if I, this is a plane, and if I put my finger on the plane, if I put it so it's laying flat onto my tablet, and the other line is on that same plane, they're parallel if they have the same slope, and the result is they never intersect. Whereas these two lines don't intersect either, but they're not parallel to each other. These are parallel, but those are not parallel. So just because two lines don't intersect doesn't mean they're parallel. Two lines in the same plane that don't intersect are parallel. These are called skew lines. So it's kind of like if you took a line on this wall going this way at this height, and you took a line on this wall at this height, they're never intersecting. This one's going to go here, and they're going to miss each other. But so that's just a different name. And then you have perpendicular lines, which are a big deal. you know, in physics, we make, well, not sometimes we make things perpendicular just because of convenience. We deal with, you know, if we're talking about speed of something or displacement of something, you know, we have an x displacement and a y displacement, which are perpendicular to each other. So typically, you can change your coordinate system. It doesn't have to be vertical and horizontal. It could be at some angle, but there is the requirement that they're always perpendicular to each other. So it's a big deal that things are perpendicular. If you have a plane in space and you have a point somewhere here, it turns out that the shortest distance between this point in space and this plane is a line that is perpendicular to the plane. So to find the shortest distance, you have to use that fact. So distances between two things, a lot of times the line connecting those two things is perpendicular to give you the minimum distance. So it's important to know how you know whether two lines are perpendicular with each other. And in 2 dimensions, it's pretty easy. In 3 dimensions, it becomes a little more difficult. Yeah, the third dimension is z, so you have x, y, and z. Pardon me? Well, you can't show that physically. I mean, you can have a 4th dimension, but you can't represent it in our 3-dimensional space. So the 4th dimension is usually time. So you can show 2 of the variables and time as the 3rd dimension, but you can't show 3 dimensions and time in something that we can visually see. So it says, if neither is vertical, 2 perpendicular lines have slope that are negative reciprocals. That is, their product is -1. Also, 2 lines with slopes that are negative reciprocals are perpendicular. Every vertical line is perpendicular to every horizontal line. So the key thing here in getting this right is understanding this whole concept of negative reciprocal. So so here's a number, and first we're going to just do the reciprocal, and negative reciprocal. Might not be spelled right, but that's okay. So the easiest ones to demonstrate are just simple rational numbers. So to do the reciprocal is you just switch the numerator and the denominator. And you can see if I multiply these 2 together, I'll get 28 over 28, which is 1. So that's the result of reciprocals. A reciprocal is a number which, when multiplied by the original number, results in 1. But from a practical standpoint, if you have a rational number, you just switch the numerator and the denominator. So the negative reciprocal is going to be -7/4. If I had negative 10/3, the reciprocal of -10/3 is -3/10, and the negative reciprocal is +3/10. If I did 4, or 1/4, the reciprocal of 1/4 is 4 once, which is 4, and so the negative reciprocal will be -4. If I start with a whole number like 3, sometimes that may seem like it's hard, but if you just rewrite it as a rational number where the denominator is 1, there's no reason rational numbers are just ratios of integers. You just switch them. So it becomes 1/3, and the negative reciprocal is -1/3. So if I ask the question, what is the slope of a line perpendicular to the line between points -1, 7 and -2, 3. So all you have to do is find the slope of this line and then find the negative reciprocal of that slope, and that'll be the slope of any line that's perpendicular to the original line. So the slope in this case, let's put, I know we're running out of time, but we're still going to write these in just to show you how important it is. So you have y2 minus y1 over x2 minus x1. So you have 3 minus 7 divided by -2 minus -1. So that becomes -4 over -1. So it's -2 plus 1, which is -1. Again, we said we're going to let the negatives cancel out. So the negative reciprocal, so we can say a line perpendicular to the line has a slope of -1/4. So this is 4 over 1, so the reciprocal is 1/4, and then you put a negative sign in. So here's some homework problems to work on. There are some word problems, and I'm just going to ask you to work them for the homework. I probably won't put anything on the test relating to word problems, but I will ask you to calculate the distance between points, probably ask you to calculate the slope of a line, maybe plot a line given a point and a slope. Those are the things that and I'll include that in the review, so when you watch the review, you'll know exactly what I'm looking for, since we didn't have a huge amount of time to get this completed. Yes, I'll send you a link, and I expect I'll have it done no later than Monday. So you'll have Tuesday, Wednesday to study for it. But if you want to study for it, just if you just study what you did in the previous test. I'm not going to put anything new, except maybe the statistics. So that'll be something that I haven't put on a test. So. Huh? Thursday at 10.